Okay, hello everyone. My name is Alex. Very glad to be here today in Taiwan. This is my first time I'm giving a talk, so I'm quite nervous. That's maybe an understatement. So, I'm a front-end developer. I live in Tokyo, where I moved there from St. Petersburg, which is in Russia. I work at Engo. We built like most popular online language learning platform in Japan, which is growing in Taiwan, actually. So outside of my daily work, I like doing web security. So I hack things for fun, and recently started doing so for bounties on the HackerOne platform. So today we'll be talking about web security, and hence the name of this talk, Escaping the Web of Insecurities. Nowadays, people are more or less aware about accessibility, for example, and there's a certain effort to make it more of a known issue. People also know that they need to maintain their bundle sizes to make sure their apps work on slow connections. However, the same effort to promote application security seems to be not so prominent. Like, well, I can make sense of my code myself, so how would anybody else will? So having an accessible application is important, but nobody will want it if you leak everybody's passwords. And this is what we will focus on today. So for many companies, security becomes the top priority only after the worst has happened. And in general, a breach always leads to at least reputational damages, at least. And nobody wants to be known as the company that recently got hacked. So let's try to talk how we can prevent this from happening. Today, we'll take a look at different types of vulnerabilities that exist, try to understand how they happen, take a look at some case studies from my experience, and see what could be done to prevent them. And the best part is that security is a universal concept. So once you master the common signatures and methodologies, the programming language doesn't matter, like be JavaScript or something else. Of course, for example, XSS is only applicable to the web, but the others that we'll see today are actually universal. And before we dive into vulnerabilities, one question, or maybe two questions. So in this hall, who thinks about security when writing your code or reviewing the code of your colleagues? If you can please raise your hands. Okay, I can see one, two maybe, three. Okay, and well, the second question was like, who has the security embedded in your software development lifecycle? But anyone? Okay. So these are the type of attacks we'll see in depth today. We have a lot of material to cover, so at least XSS will probably like fly through, so we can have time for other stuff, because maybe everybody knows about XSS at least. So XSS, the most basic thing for the web. It stands for cross-site scripting, and out of all the vulnerabilities, I expect that everybody probably heard about it. If not, it's okay, of course. So the term first appeared in the year 2000, along with a bunch of other candidates for the name. And initially, vulnerability was described as loading malicious JavaScript from a separate resource, hence this name, cross-site scripting. And the first letter is X, as far as I know, just to avoid confusion with CSS or cascading style sheets, which is a nice choice. And nowadays, there are many more vectors than, of course, loading an external script, and we'll talk about it in a second. So let's recall what XSS is about. XSS is when an attacker is able to somehow inject malicious HTML or JavaScript in the context of the web page. So there are a few classes of XSS that are usually being discerned. So reflected, stored, and DOM-based. Let's first focus on the reflected, or maybe not focus yet, but just talk about what it is. So reflected XSS is when you have, let's say, a query parameter, and the content of this parameter is being reflected on the page. If that parameter is vulnerable, this is a reflected XSS. So in this example, you have a browser page, and the query parameter named query, which is very original. And the value from this parameter is being injected directly into the page. And so if we inject the script there, we get a script on our page that is being executed, which is probably not what we want in a production application. So the next thing is the stored XSS. And the Stored is when we have some content on the page. So user can, for example, post a comment, and that comment is not sanitized properly, and the content is now there to stay. So every time somebody enters this page, the malicious content will be triggered. And this is even more dangerous than reflected ones. But so this is basically the stored XSS. As you can see in the screenshot, there's a malicious user who posted the script. Now every time somebody will enter this page, this will alert their document cookies. But of course, in the real-time situation, this could be much worse. And lastly, the DOM-based XSS, which is a type of vulnerability that is based on the concept of sources and sinks. So a source is basically a JavaScript property that can be controlled by attacker, like location.search, location.hash, whatever you name it. And the sink is a function or a DOM object that allows JavaScript execution or HTML rendering. So this could be document write in our HTML, eval, of course, or set timeout, which takes a string. And DOM-based XSS is basically when a data from unsafely processed source is being written into a dangerous sink. So if you're wondering how this is different from, for example, reflected XSS, the difference is the vulnerable part of the application. So in reflected and stored XSS, the server-side code is vulnerable. And in DOM-based XSS, the vulnerability lies in the client-side code. So how does it happen that the input is unsafely processed and XSS comes to life? Well, here you can see two examples of some user input. And one of them is sanitized and the other is not. And as you can see in unsanitized input, the brackets are valid HTML control characters. So if injected into the page, the browser will parse them as valid HTML. When this happens, the attacker basically controls the content of your page. They can inject content, execute scripts, whatever, you name it. So to sanitize your input, you need to take the significant characters, so the ampersand, left and right angle bracket, double quote, and single quote, and convert them into corresponding HTML entities. So these are 4 horsemen of apocalypse. And there are only 4 of them because ampersand is quite hard to actually come up with an attack vector to, but the other ones are easy to screw up with. So do this, and in most common cases where you just insert user content inside of the tags, you are safe. With exceptions, of course, which is if you are injecting user content into attributes, and for some reason you left the attributes unquoted, which is valid for XML, you get a much worse scenario where you have to basically encode just about everything, and there are a million ways to break out of the attribute in this case. So you better just quote this attribute. Don't listen to people who say that, oh, you know, you don't really have to quote it, it's just useless, redundant. No, it's not. Now, nowadays, a lot of applications use React, Vue, so you don't necessarily interact with sinks or sources in the daily basis, and you probably think, well, I'm basically safe, right? Because these frameworks, libraries, are usually escaping the content automatically for you, right? Unless you specifically tell it not to. Well, yeah, there is a way to screw up still, because you can specifically say to render unsafe HTML using something like dangerously set HTML in React or VHTML in Vue or whatever in Angular. And if you're not thinking thoroughly about the consequences, this can lead to an XSS attack in a React or Vue application still. So finding XSS in these applications is possible, and it happens sometimes because people still use those attributes. And it's quite easy to search for these patterns on the web, given how applications come with the source map, so we can just fire up the DevTools and start looking into source code, looking for these patterns, and then just see how if there's a user input involved and how it's being processed. So how do you not defend yourself? Well, do not sanitize HTML with regular expressions, please. So this is something that comes up quite often. But if you're using regex to just find and replace control characters, it's fine. But if you're trying to match tags or sanitize attributes, it's wrong, and you are vulnerable. And if you're doing that, this is how you look. This is basically a game of whack-a-mole. So let me show you something. These are all the ways to evade your regex XSS filters. This is a small sample, of course, but all of these are basically valid HTML examples. And some of these are taken from OWASP wiki, some are from the Payload All the Things projects, but are you sure you can make a regular expression that can match all of those? I think you can't. And in fact, I can prove that you can't. We won't get into much detail, but there is such thing called Chomsky hierarchy. And this is basically a hierarchy of language grammars. And each top level is a superset of a level below. So the definitions themselves are quite complex and involve some math. And we're not going to get into this here. But what you need to know is there are regular expressions are made to describe type 3 Chomsky grammars, which are regular grammars. Now, XML is a type 2 grammar, which is a context-free grammar. So this means that XML grammar is much more complex. And you mathematically cannot use regular expressions to accurately describe XML. So if you need to sanitize XML, use an XML parser, not regular expressions, please. Now, let's talk a little bit more about defense. So another good way of defending against XSS is to set up a CSP, or content security policy. This is a mechanism that makes browser enforce a certain set of rules regarding the content loading and script execution. So with CSP, you can implement a fine-grained control of where the scripts can be loaded from, whether you allow inline scripts at all, or only external scripts, or maybe you allow only external scripts from subdomains. So what kind of images can be loaded, and so on. Basically, a properly configured CSP can prevent an XSS from happening, even if you failed at sanitization of your content. And there's a lot of material out there how to configure it, so we're not getting into details here about this as well. But keep this in mind, and if you haven't already, please go and learn how this works and maybe apply this to your application. It will make you more secure, basically for free. Another thing that I wanted to mention is the trusted types. So trusted types is an experimental new content security policy in the browser API. It's still in early development. It's only supported by Chrome at this moment, as far as I know. And maybe it's Chrome 73 to 76, it was under the flag. In the new Chrome, I don't really know in 77. But still, so what it does is it blocks interaction with browser things using the strings. So it makes the browser things safe by default, as opposed to where you can just put the strings into them. So to interact with them, you need to implement a thing called template policy that pre-processes the data before handing it to the sink. And the idea here is that with trusted types, the only place where you can introduce XSS is in the code of template policies. So knowing that, it's much easier to spot and fix these mistakes during code review. And this is quite an exciting feature. It's being praised as something that will put an end to DOM-based XSS. So we'll see if it lives up to the promise. And sometimes, though, I've seen applications that wanted to allow HTML for formatting purposes or something. And these apps didn't opt in to use Markdown for some reason. But let's imagine that you absolutely need to use HTML that is being generated by user, but you don't want to expose yourself to an attack. So what should you do then? In this case, like I said, you will need an HTML sanitizer that is based on XML parser and the whitelist of allowed tags and attributes. And the whitelist is a very important point here, because never use blacklists. So there are so many ways, so many barely known tags or attributes that you will forget and your sanitization will fail. And just to give an example, so here are examples of tags and event handlers that probably you cannot remember off the top of your head. And imagine making a blacklist that has all of this. Oh, this is quite a task, I would say. And lastly, so a good way to prevent vulnerabilities from happening is through a code review. So your colleagues can spot something that you haven't while writing your code. And some good patterns to look for is string concatenations of tags with variables. If this happens in modern applications, I assume that it doesn't happen so often, but still. If you concatenate variables derived from user input with tags in string interpolation, all uses of sources and sinks. And basically, when you code review, it's good to think like an attacker and try to break your own application. This will do a lot of good to you. So let's recap the XSS part and move forward. So escape control characters when dealing with user input, Keep an eye on the use of dangerous HTML inputs, outputs in the React view or whatever. Don't take them lightly. Don't filter HTML with regular expressions, please. Use context security policy. And if you need HTML, absolutely, use a sanitizer based on HTML parser. And remember that blacklists don't work. And trusted types will maybe save it all at some point. So let's move to something more interesting now, SSRF. So SSRF stands for server-side request forgery. And how does it happen? So sometimes we have a functionality when our server goes and fetches some data from some other remote location for our user. So it might be an image, it might be a new avatar, it might be a zip file or something. A good example of this is on DigitalOcean, you can ask the script to fetch a droplet image from somewhere else, since these images usually weigh a lot, like tens of gigabytes. And it's probably not always an option to upload them using your browser, because it might trigger the limits, it might not go well with your internet connection. And this functionality itself is not a vulnerability, right? But only if you strictly define where your server can go and where it cannot. So in case you give it unlimited freedom of choice, this is where it becomes a problem. So the real-world example that I discovered in a specific team collaboration chat a while ago is there was such functionality to fetch a file from anywhere in the internet and attach it to your message. And for a non-malicious user, this will serve as a way to attach his, I don't know, cat picture to the message. But for an attacker who wants to compromise our system, though, this is an opportunity to exfiltrate data that they're not supposed to see. So a malicious actor can insert a local address and fetch the data from our intranet. And you might have some services running on the same host as your application, just on the different port, and that port might be not exposed to the internet. And you might have like sensitive services there that are not protected or anywhere in your internal network. And the attacker now has access to those services, and this is probably not what you want. In fact, in the modern world where things are hosted on the cloud services, there's a specific thing like metadata endpoint that hosts private keys, provisioning scripts. It might contain credentials. For AWS, by gaining access to private keys, you can completely expose S3 buckets on the account, and these S3 buckets can contain your database backups or source code or you name it. So this is pretty sensitive, but now we have to talk like how do we defend against this? And obviously, we need to filter where this server can go and where it cannot, and we need to do it carefully. And so this is where I need to reiterate that dumb blacklists don't really work. And if you implement a URL filtering based on a blacklist, here are all the ways I can bypass it and still extract information from your local host. So I can write the IP in the URL using decimal or octal notation, so believe it or not, but that is a local host. And that is a valid URL. I can register a custom domain and make it resolve into a local host or an Amazon endpoint. And I don't even need to register them. There are services that do exactly that. I can use IPv6 notation, or I can use some esoteric methods to abuse parser, especially if you wrote your own regular expression to parse the URL. This could probably work. And depending on the situation, this might be tricky, but there are two cases basically. Either you allow requests to any IP out there, and in this case, all you're left is with is the blacklist, or you allow requests to only specific IPs, in which case you can implement a proper whitelist. Now let's first talk a little bit about the whitelist. So in case of whitelist, you can mount several layers of defense here. You can validate the domain hostname using a proper URL parser. Don't roll your own rejects. URL parsers are hard to write, and they can be abused. Even the known URL parsers sometimes have vulnerabilities discovered. Second, validate the hostname against your whitelist, of course. And third, resolve the domain on the server side and make sure that it doesn't belong to any of your local private networks. So some might say that the part with the resolving is a little bit redundant, but it actually can save you from some DNS trickery or a rogue subdomain pointing into your local address, so it never hurts, really. Now with the blacklist, things are more complex because, as we already know, blacklists are weak and they are hard to implement correctly, but sometimes we still have to do it. We don't have a choice. So what we can do is, first of all, absolutely resolve the domains that the user sends your way. Make sure that the provider or resolved IP is not in the local intranet, so make sure that it's public. To do that, you can validate the IP against a list of loopback, private IPv4s, and private IPv6 addresses. One additional protection layer that is suggested by OWASP is to try and resolve the IP, the name using an internal DNS resolver, which only knows about your local services. So if this resolver responds that it doesn't know the domain name, then it's probably a public one, because your resolver only knows about the private things. And lastly, disable any sort of redirect following on the crawler that will fetch the exact data, otherwise all is in vain. And lastly, for all of those strategies, validate the protocol, because with all this defense, it would be silly if you fall the victim of file protocol and your etc password will be stolen. And this is it for SSRF, so let's move on to the next vulnerability now. And the next one is the IDOR, or Insecure Direct Object Reference. So if previous two are quite well known, I think, this one is probably not so much. Again, I don't know, maybe please raise your hands if you heard about IDORs before. Nobody, okay. So this is actually quite simple one. In nature, at least. So despite being very simple, they're quite high severity usually, as they allow access to or modification of private data. So imagine you have a shop, and after a user completes the purchase, you display the order summary with some data like shipping address, customer phone, any other customer data, etc. And you're fetching this order using an ID parameter, and that ID parameter is the actual ID of the record in the database. And if you don't enforce proper access controls, an attacker can guess the IDs of other records and collect a lot of customer data, and this is probably not what you want in your application. So this might seem like a little bit silly example. You might think, oh, I always think about access controls and I won't make such mistakes. So let's take a look at the more tricky example, something I found in the same chat application. So again, this application, a collaborative chat, looks like Slack, but not Slack. It's similar in nature, written in JavaScript, specifically Node.js, and the application allows to add attachments to your message. And this could be another message, another file, or something else. And the way it's being added is like this. So we have this JSON structure, which is a mock, of course. But using an ID of the entity in the array of attachments, we can basically, attach something. And so what I've done is I tried to modify the message creation request to add an attachment that doesn't belong to me. So this is where I got an error, and access control was properly enforced. I noticed. So, however, the other thing that I noticed is that if you add a random ID that doesn't exist, definitely, then it stays in the array of attachments. And I figured out the way how IDs are generated and tried adding a few IDs of the messages that don't yet exist, but will exist in the future, will be next to comes. And you probably get it already, but like on a second account, I sent a message to a third account in like a private exchange. And boom, like my first account had all the future messages attached to the original message. And this is basically IDOR, and the application relied on initial filtering to enforce access controls, but it didn't check, like if the ID didn't exist, then it passed the access control check, and it didn't check later when pulling the records from the database whether the user can actually access them. And this is where we get a vulnerability. So very interesting example in my opinion, and the team refused to acknowledge that this is actually like something that somebody will ever do, but this is the usual security stuff. People are, for some reason, don't like to acknowledge that things exist. But yeah. this is how this can happen. Now, let's discuss what could be done to prevent this from happening. The most meaningful advice here probably is to make the IDs of the entities non-enumerable. So instead of having an ID mapped directly to the database object and be like 1, 2, 3, 4, 5, which is easy to figure out, you can use a key that is maybe indirectly mapped to the entities. But honestly, in my opinion, the easiest way to do this is to use GUIDs. I should have included the example of GUID on this slide, but yeah. The thing is, GUID is a huge random string of letters and numbers, and these are impossible to brute force. So, and the best thing is that usually they're supported out of the box in a lot of ORM's frameworks. So, not only that, but the fact that they're impossible to brute force means that if you actually manage to screw up the access controls, it's not going to hurt your application because the other IDs will be still impossible to brute force, so you'll be in the clear mostly. And of course, the other piece of advice, which is less useful maybe, is that when fetching any sorts of objects from database to present to user, always remember the access context. So if an object belongs to a certain user, maybe it should be only visible to a certain user. But of course, unlike the IDs recommendation, this is something that could be easily overseen. It cannot be reliably used in your daily coding because sometimes we get tired and miss seemingly obvious things, and it's okay because we're all human, and humans make mistakes, and the one who doesn't make mistakes probably doesn't do anything. So once again, code review by the team helps a lot here. Your colleagues may help you spot things that you have missed, and because yeah, you work countless hours on some problems and you just don't see it so clear now. So a fresh pair of eyes always helps. And these were 3 quite popular vulnerabilities that can give you a bad time, but okay, let's reinforce the paranoia. What else can compromise your application? So timing attacks. Now, or we can say string comparisons. This one is more exotic and is quite hard to exploit, but still quite interesting to talk about, and it can affect you if you roll your own authentication, for example. And it's definitely not easy to pull off. No, and it requires quite an effort with serious approach to measurements and statistics, but it's still quite doable, and there are research papers out there where people have done this. And a timing attack is when we make a request to the system and then measure how long it takes to respond. And by measuring the difference in response times for different parameters, we can, for example, brute force a sensitive access token in a short amount of time if the system is not protected against this kind of attack. So let's first recap how strings are compared. The naive implementation of string comparison is when we go over the characters one by one and we see if they match. And so if one character doesn't match, we bail from the algorithm. And as you have probably guessed, is if the first non-matching characters is the first one in the string, then we bail quite early. If the first non-matching character is the 5th or somewhere close to the end of the string, then it will take some time to go there. And by measuring the difference in the response time for the strings that start with different characters, we can brute force the entire string. And if you're right now thinking like, where could I have done such mistakes? So common places to look for is something like token-based authentication, they forgot password tokens, API keys, something like this. And how do you actually defend from this? So to defend, you need a secure comparison algorithm, basically, that is valid for your platform. So a secure comparison algorithm will do the following for you. So first of all, it will convert the strings to hashes of equal length. And second of all, it will compare every character until the very end of the string, even if some of those characters are already not matching. So these measures will make the comparison constant time. Yeah, and with these you can achieve constant time comparison, and in sensitive places of your application where you compare like access tokens or something, you should use that and not just naive comparison. Otherwise you could be vulnerable at maybe chances are nobody will actually like try to do this, but you never know. It just takes a committed attacker to perform this. Okay, so what else can ruin our day?
File uploads. So file uploads is just, yeah, whenever a security researcher sees a file upload field, it's like fire of hope, because file uploads, if done incorrectly, they can introduce some serious holes in the system, leading up to remote code execution, like data exfiltration, or much more. And maybe you have implemented file upload, but you forgot to check the extension at all. And now if a server is set up to execute the file that has maybe it's a PHP file or something, and the attacker knows the location of the file after it has been uploaded, and if the file is accessible from your web server, then you get a remote code execution, which is basically a king vulnerability in the sense of it gives the attacker,
in most cases, complete control over your web server, and this is a checkmate. Maybe you did check for an extension, but you've done it lazily. And this code maybe was written on Friday night, and you're like, oh, I want to go home. And you did it like this, for example. And then we apply like double extension and still upload whatever we want. And I'm sure you haven't forgotten, but I have to remind again that blacklists are bad, and if you're trying to blacklist extensions that you think are dangerous, somebody will come up with an extension that you forgot, and you will end up with some PHTML or something and still get the code run at your server. So to be safe, again, always use whitelists. And a little bit of an example. So let's say you've done everything properly and you don't let user upload anything other than images. So let's say it was an avatar upload functionality for the profile, and the following are the allowed formats, so JPEG, PNG, GIF, SVG. And this sounds bulletproof, right? Are you now safe? So to make a clarification, files would go in uploads directory on the same host as your application, so it's served from the same domain. And do you think we're safe with this kind of conditions? Raise your hands who thinks we're safe. Okay, Eric thinks we're safe. Okay, so the thing here is that SVGs can have scripts embedded into them. So if you navigate to this file directly, you get an XSS on your origin that has basically user cookies. And if you don't have HTTP only or something, yeah, there goes your cookie jar. It could be still stolen. So the solution here is to serve assets from a separate origin. It's the easiest way to defend. This way, even if the script is embedded into the SVG, the attacker will not really gain anything by executing it, like maybe some loss, but no real impact. And when speaking about vulnerabilities, the impact is more important than anything. And last thing that I want to cover is business logic errors. So for this kind of flaw, there is really no formal definition. And I tried to come up with one, but it's like quite complex. So instead, let me just give you an example from one of my findings again. Now, imagine a shop where you can register an account and have some balance associated with this account. So this balance can be topped up using several payment methods, like a credit card or an external payment system. Now, to visualize, this is how the flow usually looks. So the user requests from the application that he wants to pay, or they want to pay, and they're being redirected to the payment provider. Then they pay and then get back to the initial page, and then the payment provider calls back the application on some separate endpoint, signalizing that, yeah, the payment was a success. So when you see this, one thing that crosses your mind is that actually, if there is this endpoint, you can interact with it yourself and see how it behaves if you put there some data that it probably doesn't expect. And so in this example, when I was looking at this application, I dug up the docs for the payment system. I found this endpoint and what kind of data it expects. And I initialized the top-up transaction, noted all the parameters like ID and everything that was passed to the payment system. I backed out of the payment and I crafted a success message and sent it to the callback endpoint. And it looked something like this, so no interaction with payment provider whatsoever. So I sent some data to the callback, and it answered me with an error, and I was like, well, this is not exactly unexpected. So it said that it cannot find a transaction with such ID. I tried a few different other payloads, seemingly with no luck, because it kind of answered with the same error message. And then I refreshed the page, and the account balance was exactly my amount in the fake payload times the time I tried this attack. So, surprise. And is this vulnerability, right? It absolutely is one. It's free money, but it's not some specific flaw in underlying software that we mentioned before. It's just your code is making wrong turns. And it's likely happened because this endpoint wasn't really made with security in mind, because it was made to satisfy messages from payment system. And it had some validation in place, but probably if the message said that the operation was success, it treated the message as such, not really expecting somebody to send malicious payloads to this endpoint. So the lesson here is not exactly new. Again, all data that comes to your application from the external users, external services should be treated as malicious, always. So even if you only expect data from a trusted actor, you should take measures to prevent bad things from happening. Another thing is that just because something is not being used publicly doesn't mean it's not going to be discovered. So security through obscurity is no security. Don't think that if you can hide something, nobody will figure it out. And of course, blacklists are bad. And do a lot of code review, so your colleagues are your partners, and they will be the best way to ensure that your code is safe, especially in the mission-critical components like I just mentioned. And remember that no attacker is some Adam Jensen guy from Deus Ex with a magical hacking device. So every breach is just a small programming mistake that turns out to be a security problem. And here are some useful links. So OWASP Wiki, which is a great place to start learning about security. It has all the different kinds of vulnerabilities, all the prevention measures, that stuff. So another thing is payload all the things. This is basically a resource for hackers because it has evasion techniques, but if you're defending, it's good to see what kind of ways people use to attack your application, because then you can do the opposite and don't let them win. And a link for the blog post about the trusted types, because it's an interesting thing. There haven't been any updates recently, but if you want to dive deep into that and see how it works, please do. And that's all I have for you. If you have any questions, I will be glad to try to answer them. Thanks very much for attending.
Hi, I'm wondering does you have any kind of experience that when your server need to take several requests from client side, and the request 1 and request 2 and request 3 is related, so the request 2 may need to take some kind of parameter from request 1's response, and so does the request 3. So when hacker find the pattern of your parameters, they can skip the request 1 or request 2 and directly invoke the request 3 with the correct parameter. So they can skip some of the check logic in your server side. So do you have any kind of experience that how to prevent this situation?
I would say that if we're talking about the requests that are not something that user has to do specifically 3 times in a row, then the best way of doing this would be to actually have a separate sort of endpoint that makes all those next requests for the user. So instead of having the user go into one place and then second place and then third place, you can have your server encompass all these requests, and so the user requests just one endpoint, and you keep all the state between the requests on the server and have your server make those requests for the user, combine all the data, and then return it to users. So this way you don't have any synchronization issues probably. That would what I would do.
好，那我们今天就是这一场议程的时间差不多，然后外面